Dear students, here is the topic inverse trigonometric functions. Inverse trigonometric functions problem comes under question number 16 of your final examination question paper of 1A. This question carries 4 marks, means it comes under short answer questions. So here we are sharing you 5 questions from inverse trigonometric functions. All these 5 questions are very much important to you. These are the 5 guess questions which we may expect in our final public examinations. So here I am trying to explain you all these 5 questions. First of all, I am choosing this question. Prove that tan inverse 1 by 2 plus tan inverse 1 by 5 plus tan inverse 1 by 8 is equal to pi by 4. This is my question which I am choosing now. So here I have taken the question. Prove that tan inverse 1 by 2 plus tan inverse 1 by 5 plus tan inverse 1 by 8 is equal to pi by 4. So for this problem solvation, I am considering LHS, left hand side part of the question. What is left hand side part? That is tan inverse 1 by 2 plus tan inverse 1 by 5 plus tan inverse 1 by 8. This is the question we have considered. So in this question, you can choose any two terms. If I consider first two terms, what formula I can apply? I can apply the formula for tan inverse x plus tan inverse y. What is the formula for tan inverse x plus tan inverse y? It is tan inverse of x plus y by 1 minus xy. This formula applicable only if xy value is less than 1. Here x means 1 by 2, y means 1 by 5. If I consider x into y, this is 1 by 2 into 1 by 5. That is 1 by 10. That is 0.1, which is less than 1. So clearly we can apply this formula here. Clearly we can apply this formula. So if I apply that formula here, tan inverse 1 by 2 plus tan inverse 1 by 5 can be written as tan inverse of x plus y 1 by 2 plus 1 by 5 by 1 minus 1 by 2 into 1 by 5. Okay, plus tan inverse 1 by 8 already there, we are mentioning that again. So tan inverse, in the numerator what we can take LCM, that is 10. Here we'll get 5 plus 2 by 10. In the denominator also 10 is LCM. Here we'll get 10 minus 1 plus tan inverse 1 by 8. So here both the denominators get cancelled. You got the answer as tan inverse of 5 plus 2, 7 by 9 plus tan inverse 1 by 8. Again, here also, here what is the value of 7 by 9? You can take it as x, and 1 by 8 we can take it as y. And if you take x into y, that is 7 by 9 into 1 by 8. 7 by 8 nines are 72, which is also less than 1. So if xy is less than 1, surely we can apply the formula for tan inverse of x plus y by 1 minus xy. So again, if I apply the same formula, tan inverse of 7 by 9 plus 1 by 8 by 1 minus 7 by 9 into 1 by 8. So tan inverse of 7 by 9 plus 1 by 8 by 1 minus 1 by 7 by 9 into 1 by 8 can be written as 7 by 8 nines are 72. So in the numerator also we can consider the LCM as 9 8s are 72 only. So here we'll get 8 into 7 plus 9 by LCM 72. Here we'll get 72 minus 7. So again both the denominators will get cancelled. So you got the answer as tan inverse of 8 7s are 56 plus 9 by what is 72 minus 5? 72 minus 7, that is 65. So here you got it as tan inverse of 56 plus 9 is 65 by 65. You can write it as 65 by 65 is 1. When we'll get 1 in tan values? 1 can be written as tan 45. That is tan pi by 4. Tan inverse of tan pi by 4, answer is pi by 4, which is your RHS for this problem. So just applying a single formula. What is that formula we are applying here? Tan inverse x plus tan inverse y is equal to tan inverse x plus tan inverse of x plus y by 1 minus xy. We are applying only this formula for solving total problem. So how the marks are distributed here? For applying this formula, here we'll get 1 mark. Here we'll get 1 mark. Again, for after simplification, again you are considering the same thing and you are applying the same formula. Again here also you will get 1 mark. 2 marks we got it up to here. And for simplification like this, here 1 mark, and conclusion also 1 mark. Total 4 marks are distributed. So for applying the formula only, you are getting 2 marks, and again for simplification 2 more marks. Thank you. Dear students, here we are solving second problem. What is our second problem means? Prove that sin inverse 4 by 5 plus 2 tan inverse 1 by 3 is equal to pi by 2. This is what we need to prove. The previous problem is completely in terms of tan, which we have felt comfortable. That's why again if I want to convert the total problem in terms of tan, it will be very much easy for us. Listen to me carefully. If I want to convert this sin inverse term in terms of tan inverse, what happens? If I can take, let A is equal to sin inverse 4 by 5. Okay. So sin A value will be 4 by 5. If I consider a right angle triangle with angle as A, this is a right angle triangle. Sin A formula is opposite side by hypotenuse. So I can write opposite is 4 and hypotenuse is 5. So adjacent will become hypotenuse square minus side square. 25 minus 16 will be 9. Square root of 9 will be 3. So if I want to write this as in terms of tan, what happens? Tan A can be written as opposite side by adjacent side, 4 by 3. A can be replaced by tan inverse 4 by 3. What is A actually we have taken? We took the value of A as sin inverse 4 by 5. So sin inverse 4 by 5 can be replaced by tan inverse 4 by 3. Okay, sin inverse 4 by 5 can be replaced by tan inverse 4 by 3. For such simplification, you will get 1 mark here. Again, the second term is 2 tan inverse 1 by 3. Here also I want to find out 2 tan inverse 1 by 3. I am feeling that 2 is a little tough thing for me to simplify. So I want to recollect my trigonometric basic formulas. Through that, I am getting the formula of tan 2a from trigonometry as 2 tan a by 1 minus tan square a. Correct? From this, what is the value of 2a? If I take tan to the right side, it will become tan inverse. Tan inverse of 2 tan a by 1 minus tan square a. So if you replace a, tan a with x, if tan a is equal to x, if I substitute tan a is equal to x, a can be taken as tan inverse x here. So what happens? 2 into a, 2 into tan inverse x is equal to tan inverse of tan a. I am replacing 2 tan a, 2x by 1 minus x square. So 2 tan inverse x formula is tan inverse of 2x by 1 minus x square. Here in the question, they gave you 2 tan inverse 1 by 3. So in place of x, I need to take 1 by 3. So if I take 2 tan inverse 1 by 3 here, what it will become? Tan inverse of 2 into 1 by 3 by 1 minus 1 by 3 whole square is 1 by 9. So tan inverse of 2 by 3 by 9 minus 1 by 9. That is tan inverse of 2 by 3 by 8 by 9. So we know that denominator of the denominator goes to the numerator. So 2 by 3 into 9 by 8 it will become. So if I want to simplify, 3 3s are 2 4s are. Correct? So this can be written as tan inverse of 3 by 4. Therefore, I can replace 2 tan inverse 1 by 3 by tan inverse 3 by 4. Okay? This can be written. So, if you take sin inverse 4 by 5 as tan inverse 1 by 3, you are getting 1 mark here. And again 2 tan inverse 1 by 3 as tan inverse 3 by 4. Again for this simplification, you are getting 1 more mark. After this, now we are coming to solve the problem. What is given in the question? They have given LHS. You need to prove it as equal to RHS. What is LHS here? So what I am doing is, I am considering LHS. LHS is sin inverse 4 by 5 plus 2 tan inverse 1 by 3. Sin inverse 4 by 5 we are replacing with tan inverse 4 by 3. Okay, this can be written as tan inverse 4 by 3. 2 tan inverse 1 by 3 we are replacing with tan inverse 3 by 4. This is tan inverse 3 by 4. So tan inverse 4 by 3 plus tan inverse 3 by 4 I got. So tan inverse 4 by 3 is fine. Tan inverse 3 by 4 I can write it as cot inverse 4 by 3. Correct or not? So then we can apply one formula which we are very much familiar. Tan inverse x plus cot inverse x. If x is same for tan inverse and cot inverse, answer is pi by 2. Using this formula, tan inverse 4 by 3 plus cot inverse 4 by 3 will become pi by 2, which is your RHS. Hence proved. The problem is very much easy for us now. Okay, just we converted the total problem in terms of tan and we substituted the tan values, and tan inverse x plus cot inverse x we got, which is equal to pi by 2. Thank you. Now we are solving third problem here. What is our third problem? Sin inverse 3 by 5 plus sin inverse 8 by 17 is equal to cos inverse 36 by 85. Here in every problem we have converted till now, we have converted it in terms of tan and we have simplified. If you want to directly solve it in terms of sin or cos, that is also fine. You can take it as A and this as B. So then what happens? You need to prove that A plus B is equal to cos inverse 36 by 85 you need to prove. That is, to prove that, if you take that cos inverse to the left side, what happens? It will become cos A plus B. If you prove cos A plus B as 36 by 85, then also it is fine. So now you have to apply what formula? Cos A plus B formula. What is cos A plus B formula? Cos A cos B minus sin A sin B. By applying that formula also we can solve this problem. So I am applying that. Here what I am doing is, let A is equal to sin inverse 3 by 5. So what happens to sin A? It will become 3 by 5. In right angle triangle, if I consider angle as A, opposite side is 3, hypotenuse is 5. So automatically adjacent side will become 4. From this triangle I can write cos A value as 4 by 5. Okay. After that, what we have taken, we took the value of B as sin inverse 8 by 17. So from this, what is the value of sin B? That is 8 by 17. Again, if you construct a right angle triangle, if you take the angle as B, opposite side is 8 and this is 17. 17 square minus 88 square. Okay, 289 minus 64. Again, it will be 225, which is nothing but 15 square. So this will become 15. From this, cos B can be written as adjacent side 15, hypotenuse 17. So now we got the values of sin A, cos A. Along with that, I got the values of sin B and cos B also. Now we are applying. Now we are considering cos A plus B and we are trying to solve the problem. So here I am considering cos A plus B. What is cos A plus B formula? That is nothing but cos A cos B minus sin A sin B. Okay. So cos A cos B. Cos A value what we got? We got cos A value as 4 by 5, which we are writing here. And cos B value, what is cos B value we got? That is 15 by 17. Again we are copying here. Minus sin A value, what we got for sin A? Sin A is 3 by 5 and sin B is 8 by 17. This also we are substituting 3 by 5 and 8 by 17. So 5 sevens are, what is 5 sevens are? 5 sevens are 30, 5 17s are, 5 sevens are 35, 5 ones are 5 plus 3, 85 is LCM. So 4 15s, 60 minus 3 8s are 24. So cos A plus B value, we got it as 36 by 85. So cos A plus B, which we have to prove it as 36 by 85, we got it. If you want, you can write A plus B as cos inverse 36 by 85 here. What is A? A we can replace with sin inverse Here already we have taken A value as sin inverse 3 by 5, B value as sin inverse 8 by 17. So this will become sin inverse 3 by 5 plus sin inverse 8 by 17, which is equal to cos inverse 36 by 85. Hence the problem is proved. Hence the problem is proved. So here the marks allotment, once again we can check. For finding cos A value, here we'll get 1 mark. By using the triangle, again we are finding cos B also. Here we'll get 1 more mark. 2 marks we got for finding. After given, we have taken sin A and sin B and we got the values of cos A and cos B. So for this triangle construction and all, we'll get 2 marks. And again, for this formula and substitution, you'll get 1 mark. And for simplification, again, you'll get 1 mark. So it's very easy problem. Now we are doing the fourth problem, which is nothing but if sin inverse x plus sin inverse y plus sin inverse z is equal to pi. They have given you this value of sin inverse x plus sin inverse y plus sin inverse z as pi, and they are asking you to show this value is equal to 2xyz. So given thing we are going to write it. We are writing given sin inverse x plus sin inverse y plus sin inverse z as pi. For my convenience, I am taking these values as A and B and C. So what happens? Then we can write it as A plus B plus C is equal to pi. Pi means 180 degrees. It is very much comfortable to take. So what we have taken, let A is equal to what we have taken, sin inverse x. Then what happens to sin A value? That is nothing but x. After knowing sin A, easily we can write cos A value as root 1 minus sin square A. Root 1 minus sin square A. So cos A value will become root 1 minus x square. When sin A is x, what is the value of cos A? Sin A is x, cos A value will be root 1 minus x square. Again we took B value as sin inverse y. B value as sin inverse y. So sin B will become y. What is cos B means? Root 1 minus y square. Okay. For C we took it as sin inverse z. So sin C will become z. Cos C will become root 1 minus z square. It's very easy problem now. So we got the values. First we'll highlight them, sin B, and then we got sin C also. Sin C is z, cos C is root 1 minus z square. Now we are considering LHS to find the RHS. LHS value. In the question, what we need to prove? X into root 1 minus x square, y into root 1 minus y square plus z into root 1 minus z square is equal to 2xyz. That's why I am considering LHS x into root 1 minus x square plus y root 1 minus y square plus z root 1 minus z square. Already we got the value of x. What is x value? Just now we have highlighted here sin A value as x. Sin A value as x and root 1 minus x square as cos A. So if I substitute this as sin A and this will become cos A. Again y will be sin B. Root 1 minus y square will be cos B. Plus again this will be sin C and cos C. Okay. Sin A cos A. We got it as sin A cos A plus sin B cos B plus sin C cos C. We got like this. So after this, clearly we know the formula for 2 sin A cos A as sin 2A. So what I am doing is I am multiplying and dividing with 2 for the total terms. So 1 by 2 if I multiply and divide, what happens? It will become 2 sin A cos A. Okay, I multiplied and divided with 2. 2 sin A cos A, 2 sin B cos B plus 2 sin C cos C. So 1 by 2 into sin 2A plus sin 2B plus sin 2C. Here we have to apply transformations here. But no need to solve the total problem of transformations. Why? Because this problem is for 4 marks. If they ask you for 7 marks, we can solve transformations also. But here directly we can apply transformations formula. In transformations, we got a plus, if whenever a plus b plus c is 180, then the value of sine 2a plus sine 2b plus sine 2c. This is the first problem of transformation. Okay, if you simplify this using transformations, we'll get the value as 4 sine A sine B sine C. You must remember this formula. Why? Because this formula we are applying in inverse trigonometric functions as well as in properties of triangles also. So try to remember this as formula. This transformation question you need to remember it as formula. So sine 2A plus sine 2B plus sine 2C can be replaced by 4 sine A sine B sine C. Okay, 4 sine A sine B sine C. This 2 cancel for 2 times. So you got it as 2 sine A sine B sine C. You can write it as 2 into sine A is x, sine B is y, sine C is z. We have taken sine A as x, sine B as y, sine C as z. Okay, this what we are substituting in place of sine A, x, y, z. So sine A, sine B, sine C. We substituted it as x, y, z. We got it as RHS. Hence the problem is proved. Hence the problem is proved. Thank you. Okay. Next problem. Find the value of tan of cos inverse 4 by 5 plus tan inverse 2 by 3. Here I can see tan and tan. Here also if it is tan, the problem will be very much easy for us. So I want to convert it. Cos inverse 4 by 5. Let A is equal to cos inverse 4 by 5. Okay. Then cos A will become 4 by 5. If I construct a triangle, right angle, triangle, and if I mention the angle as A, cos A means adjacent side by hypotenuse. So what happens to the opposite side? That is hypotenuse square minus adjacent side square. So 5 square minus 4 square, 25 minus 16, that is 9. So this will become square root of 9 is 3. So opposite side will become 3. So tan A formula directly we can write it as 3 by 4. So A is tan inverse 3 by 4. What is A value? Cos inverse 4 by 5. We took it as A. So cos inverse 4 by 5 also can be written as tan inverse 3 by 4. Okay, now I am considering LHS and I am trying to solve the problem. What is LHS? What is the question? They gave you to find tan of cos inverse 4 by 5 plus tan inverse 2 by 3. Okay, so tan of cos inverse 4 by 5. I am replacing cos inverse 4 by 5 with tan inverse 3 by 4. So I am writing it as tan inverse 3 by 4 plus tan inverse 2 by 3. Here for this, which formula I need to apply? Again, we are using whatever the formulas we have solved in first and second problems, we are applying the same formula. What is that? Tan inverse x plus tan inverse y. What is tan inverse x plus tan inverse y? Tan inverse of x plus y by 1 minus xy. Always you must remember this formula is applicable only for xy less than 1. Here x is 3 by 4, y is 2 by 3. So if I consider xy, what happens? 3 by 4 into 2 by 3. Okay, 3 will get cancelled 1 time, 2 times. So xy 1 by 2 we got, which is less than 1. So 100% we can apply the formula. So tan inverse 3 by 4 plus tan inverse 2 by 3, we are applying the formula. So tan inverse, what is there? 3 by 4 plus tan inverse 2 by 3 is there. I am applying the formula now. I can write it as tan of tan inverse x plus y 3 by 4 plus 2 by 3 by 1 minus xy 3 by 4 into 2 by 3. Tan of tan inverse, both will get cancelled. Tan and tan inverse will get cancelled. You got it as numerator LCM is 12, 3 3s are 9, 4 2s are 8 by 1 minus 6 by 4 3s are 12. So 9 plus 8. 9 plus 8 is 17 by 12 by 12 minus 6 by 12. 12 will get cancelled. 17 by 6. So here the answer is 17 by 6. They are asking you only find the value. So we got the answer as 17 by 6. Okay, we can solve all problems in this manner. Every problem is comfortable in solving inverse trigonometric functions. Okay, here I helped you to solve all 5 problems of inverse trigonometric functions. Similarly, you can solve the remaining also. Thank you.